All right, today we're diving into a story of high-stakes drama, but it's all happening on a scale you can't even see, deep inside a tooth. We're talking about a tiny tool on a supercritical mission, and what happens when it takes a very, very wrong turn. So just imagine for a second, you're navigating this complex network of tunnels, right? You're on a mission, and everything depends on you reaching your destination. But then, boom, the path is completely blocked. This isn't some kind of sci-fi movie. It's a real challenge that happens in dentistry, and it all starts with one very specific goal. So let's meet our hero, if you will. It's this tiny, super flexible tool called an endodontic file, and its entire job is to be a pathfinder, to journey through these unbelievably narrow little corridors inside a tooth's root canal.
Now, the whole point of this mission is absolute precision. I mean, this file has to travel the entire length of that canal, all the way to the very tip. That specific destination has a name. It's called the working length. Getting to that exact spot is so crucial because that's how you know all the infected tissue has been cleaned out. So yeah, a successful mission really depends on having a clear shot to that target.
So this whole thing can really go one of two ways. In a perfect world, the path is totally clean, it's open, and the file can just glide right to its destination. Easy peasy. But there's a hidden danger, and that's when microscopic debris starts to build up. Believe me, this is not just a little bump in the road. It can completely block the way forward.
So, how in the world does a clear passage turn into a dead end? Well, it turns out that just a couple of small missteps during the procedure can kick off a whole chain reaction.
It really is a chain reaction. First, if the canal isn't flushed out really well with a cleaning solution, dentists call it an irrigant, these tiny particles get left behind. Then those particles start to pack together, almost like a microscopic traffic jam, until they create a solid plug. And just like that, the original natural pathway is gone. The file is now basically flying blind.
Okay, so this is the moment of truth. The file still has to move forward, but its intended path has vanished. So under pressure, what does it do? It does the only thing it can. It starts to forge a brand new path.
Since it can't push through that wall of debris, the stiff tip of the file just starts pressing into the side of the canal wall, and it begins to carve a new, artificial path, a total wrong turn on this tiny little journey. And this is how our main problem gets created.
And that is what dentists call a ledge. It's not supposed to be there. It's a man-made detour that's been carved right into the canal wall by a tool that got lost. And you know, creating this ledge has a really serious consequence.
So you might be thinking, why is this tiny accidental shelf such a huge deal? Well, because it fundamentally changes the entire map of the mission. The original destination is now incredibly difficult, sometimes almost impossible to get to.
And this is really the key takeaway. Dental experts are super clear about this. They say, once created, ledges are very difficult to bypass. See, the file will now naturally want to follow this new incorrect path it just carved, which makes it a massive challenge for the dentist to get things back on track and actually complete the procedure.
Okay, so let's just quickly run through the whole story again. It all kicks off with cleaning. If it's not thorough enough, debris can block the path. That blockage can literally force the dental file to go off course, causing it to carve that artificial ledge into the wall. And that ledge, well, that becomes a major complication that puts the whole procedure at risk.
You know, what this tiny drama really shows us is just the incredible level of precision that's needed in dentistry, where a journey of just a few millimeters can have obstacles that are measured in microns. It just makes you wonder, right? What incredible techniques and tools have specialists developed to navigate around these tiny mistakes and get their missions back on course?